So let's implement the method insert at front. Okay, copy, and I am going to end. So I need to do resolution operator. So insert at front belongs to linked list and returning nothing and getting entry, and its position we already know that we will insert it in the beginning of the list. So we will create a node. This node is something new node ptr equal to new node. So we have created one new node, and then we can set new node ptr set data set data. So new entry, so we will provide new entry and y undefined y set data. So we have here set data in class node. We have not here something node. Okay. So set data. So then we may have first case, if is empty, list is empty, then head ptr equal to last ptr equal to just this new ptr. So very simple, right? Else if list is empty, then new node will become the first and last node, and there will be just one node. And else new node ptr, we will set link head point. Before, head ptr was pointing to first node. Head ptr will become new node pointer, new node ptr. So this is something, the logic same logic we have seen in a class. We are just changing the pointers, just two steps, right? Two steps. So before, head pointer was pointing to first node. Now this node become first node, and now the new node is pointing to the node before head pointer was pointing. So very simple, right? So very simple function. So end of insert at front. So we can have another function. insert at back and adds the node, a node, a node at the back of the list. So let's copy it. So here we will define it. So linked list, and this is the body. So these two lines are same here. So new node is created, empty node is created, and then this the data is set, and then we will again check if the node is empty, so list is empty, then we will have just head pointer equal to last pointer equal to new node pointer, else we may have here some block, small block. So then last PTR, we will set link to the new node PTR, and the last PTR will become very simple as we seen in class, new PTR. So you can see you can just compare these two lines. So end of insert at back function. So these are two special cases, and we have another case. As you know, list data structure, in list data structure we can add element at front or back or any position. So we need to give here also position. So int position. So add a node at the given position in the list. So we will provide a position and the data, and we will insert this this node at the given position. So let's write a program to do this one. So we can have here, and here we will have body. So resolution operator and the class name. So this function belongs to class list, linked list, and this colon mean resolution operator. Okay, then so let's this position may be, somebody can provide first position or any other position. So let's say we may have three cases. If position equal to 1, then very simple, right? We can call this function insert at front. Then insert at front we will call, and a new entry we will provide. So first case, so if a position is 1, right? Else if another case, maybe if the position is the end of the list, that means position equal to get size plus 1. This may be another special case, and we can just call, insert at back. So already we have written two functions, so we can call this function. Else we can have some treatment. Else so we can create a node. Please remember these instructions are also here, so this function will create node. So new node pointer is created, and data is assigned, and then please see, I am writing because we have this position, we need to find a pointer before this one, right? So let's see, um, we have another node pointer, and actual capital node pointer, and previous ptr, its name previous ptr equal to get node at position -1. So please remember this function get node at. So this function get node at provide the node pointer at some given position. So this is the pointer, this is the node, pointer to the node that is just before this position. So then just here I will comment it, get the node that will be before the new node, and then now insert. So insert new node here. So how to insert? So new node ptr set link, set link of what? Previous ptr get link. If you remember, in the class I have shown you slides, and then sorry, previous PTR we will set link, set link this new one. That's it, simple. So we have this function that will uh, insert a node at a given position, insert at. So let's write now functions for deleting node. So we need some functions. Node will be returned, remove at front. Then we do not need any argument. So this function will removes the node at the front of the list. Okay. So this is the function name, and then here is the body. Okay. Remove at front. So let's write the code. Code will be very simple. So let's have a node that is something temp PTR equal to head PTR. So we have created one node that is pointing to the first node of the list, and then if we have some condition here, if is empty, that means list is empty, then return null PTR. So it means no node will be removed because list is empty. You can put here some message or error message or any other you can, if because if list is empty we cannot remove anything. Else we have to deal with the node. Okay, then we may have a special case again. Special case. Else if head PTR equal to last PTR, last is L is small, last PTR, and equal to sorry, equal sign is here. So if this condition, that mean only one node. If one node, only node in the list, one node, then we can again so if there is only one node, then we can uh, just head pointer equal to last pointer equal to null pointer. Else we may have some arrangement here. So very simple arrangement. Head ptr equal to head ptr get link, so it will be moved. No need, I think, these braces. So this is something if else structure, and then out of this one we will have return temp ptr. So head pointer basically return, temp pointer is head pointer actually, and we have moved the head pointer to the next node. So very simple. End of remove at front. Similarly, we will have another function remove at back. Removes the node from the back of the list. So let me copy this function here. So we will write here body so let's define a node pointer temp ptr and equal to last ptr. So again we will have some cases. First case is if is empty, then we will just return null ptr. Else if we have just one node, Then again it is very simple. If head PTR equal to last PTR, then again we will just have this case. Else we have to do something. So first we need to do locate second node second node to the last node, that means the second last node in node just before the last node. How to get that node? We have already defined some functions actually. Node previous pointer we defining get node at. This is the function we already have written and we will provide. So get size -1. So this is something, get size is the last node and -1 we can have. So this is the node, and now we have to just set the, so then we need to set this temp node. It is already a last node, then last pointer, last PTR. It is something previous PTR, just previous, we assign the previous one, and previous PTR we set link to nothing, null PTR. So this is something that the in else part we will do. That's it. And then return temp PTR, because the last node is kept by this temp PTR. Very simple, right? And then we have another function, remove at. We have this function to remove the node if we are just given the position. Removes the node at a given location or number. So node number 5, suppose some person say, okay, delete the node number 10 in the list, delete the node number 1 in the list. So we will use this remove at function. So we will have remove at, and we can write the body. So remove that. So first we will create a node temp ptr new node. So so again here we may have this position, maybe first position or the last position. So we may have these kind of uh, different cases. So we may have first case maybe if is empty or position is greater than get size, then we cannot delete node, right? Then just return some null ptr. Else if we have a position 1, it means it is something node at we will just call remove at front. So just we have created this node, so we will return at the end and we just provide it null pointer, and here we will provide this node. So another special case, else if pose equal to get size, that means that is something the last node. Then again we can call function remove at back. So just we can get node, and this node will be pointed by temp pointer. Else we may have some arrangement, right? And after this one we can return temp ptr. So else we need to get previous pointer, just like we have done here. So we will get this one, get a previous pointer at position -1, and then we will have very similar temp ptr equal to temp ptr equal to next of this one, get link. So this is the node we want to remove, and then previous pointer, it is a set link where next of temp ptr, get link. Get link. Please try to understand this one. So we have a previous node, and next node will be deleted, and next is we assign to the temporary node, and the pointer for the previous node is set to the link for the next one that previously pointed by temp_ptr. So very interesting. That's all. So in this way we have different special cases, and we can handle them easily. So mm, one more function, maybe one person, maybe he wants some data entry, right? Data entry is provided, and he may want to remove the element. So we can just name it remove, and some an entry, and we can then um, have some const input parameter, constant input parameter. So one entry is provided now. So again, it is not difficult. We can easily, because we have some other develop some function, so we can easily deal this kind of situation. So we need here to write body of this function. So remove function. Again we need some node temp_ptr, and we have some empty node, and then we can get position equal to get position function. We can call get position function, and we can provide and then if position is greater than 0, if this position is greater than, that mean there is a node, then we can just call this function. We can call this function here, this function call, right? This function call and get a node, and this one is else. We can have that mean no node to remove, and then we can return this temp node, and here end of remove, here end of remove add function. Okay, then we may include more functions, like we can search some node and we can get frequency of some nodes, but before so you can see now we have developed so many functions, and here you remember, in case of um, node class, we have a friend function uh, that is something overloading of the operator, this operator double angle operator of output stream. So we will have a very similar function for the list node, so that if we test this one like this one, if we make some list and the list will be printed here. So let's make it here friend function. This is a friend function, and we will have it means this std o stream, and this is something reference. So it means output stream belongs to this namespace std namespace, and here we will have syntax operator, and this is the operator we want to overload. So we need to put here some input parameters, and then we will design our system as the function. So one parameter is output stream, stream stream, and we will have some reference, and okay, let's see output, and then we may have const. So a const linked list, and we can have here one object linked list. Is there some spelling mistake? OS. Okay, we will see. Okay, it will return output. Okay, and here we will have output, and we will put here string total elements in the list, and then we may have get size function, list dot get size. So then we have another output, and we will have here output. Here just we can have a opening brace, just we are formatting, and then output. Okay, we will have some output, but because we want to print all elements, right? So here will be node pointer. So current PTR equal to head PTR. So this is something uh, we can get this one through the list. So we can have head PTR, and then we can have while loop, while current PTR not equal to null PTR. That means we want to go through all the list, then we have some loop. So in this loop we can have some statements, then output. So we just want to dereference of the current PTR, and then we want to have some comma and nothing. So this is something inside while loop, and then we want to move current PTR equal to current PTR next get link. So end while, so here end of while loop, and then after this one we can have closing brace. So and then return output, and there may be we can have one more next line, end line, right, and you can provide std and this one. So save all these things. So I hope these it is not good practice to provide here using namespace std. That's the reason we are writing this one and this one here. So I think these errors will be removed, maybe some other errors. So let's now test. So here we can have linked list dot h, and we may have some function linked list test. We can call this function. So void linked list, this is something the function name, and we may have here linked list we may have a list, and then we list dot we can insert at front some element, maybe we can have 10, and then we want to see out, we want to print list, and then we want to have another at front 20, then print list. Okay, back, and here we have another one just at position 1, and maybe 5. So then we want to print list. So let's see, we have very simple functions. Let's see what is the problem. So here is get link to create. So let's see what is the problem. Okay, this is something the problem we have to put here. So let's try again. Okay, here we have list, total elements is the list just 1, and we need some space actually here, and then 2, and then 3. So elements are added. So it is working fine. So we can just change little bit. So here we can have some space here. Okay, and no need to get more space, and then we can add more element front, and element at maybe we can have insert at, and insert at at front maybe 55, and we just need not to, and then we can have just in the beginning. So front, and then we can have more elements. We can add 120 suppose, and we can have at number 4 we can have 500. So let's see. So in the beginning our list has empty list, has not any element, and then we have just one element, then we have, and 54 55 is added number 4. So 55 is added at front, and 120 is added at back. Okay, and then 500 at position 4. 1 2 3 4. That's good, it is working fine, right? So let's also uh, test the remove functions. So remove at front, so we do not need any argument, and we can have remove at back. So then we have, there is 5, so let's remove 5. Just provide some entry, remove 5, and also we can have remove at 2, remove at, so this is something position 2. So let's see, so we can, yes, so you can see here uh, up to 6 we were adding, and then we have removed from the front 55, and then next time we removed from the end, and next time we removed number 2, 10 is removed, and then we removed 5 is at number 1 actually. So add and remove functions are working fine. So uh, we have uh, you can do more tests, and we will include few more functions, and then our list data structures, implementation of list data structure will be completed.